In Module 9, we're going to talk about how quadrilaterals are parallelograms and certain types of quadrilaterals, such as a rectangle, square, kite, trapezoid, and etc. So we're going to first start out with just what is a parallelogram and some different properties of parallelograms. So first off, a parallelogram has to be a quadrilateral, so it needs 4 sides. And the definition of a parallelogram means that it has to have 2 pairs of opposite sides that are parallel to each other. And this term parallelogram, PQRS, with symbols is written like this. So you're drawing basically a mini parallelogram. And in this parallelogram off to the side, the 2 sets of sides that are parallel to each other would be RQ is parallel to PS, and then the other one would be PQ is parallel, sorry about that, RS. With parallelograms, there are 4 main properties. So if a if a quadrilateral is a parallelogram, then we have these 4 things are going to be true. So the first one is that the opposite sides are going to be congruent to each other. So if you have a problem that you're trying to find what the x is going to be equal to make it so it's a parallelogram, then you can set those sides equal to each other and solve for the variable. If we have another property is if we have opposite angles that are going to be congruent to each other. So we need 2 sets of opposite angles that are congruent. Again, if we were solving for something, that we would set them equal to each other and then solve for that variable. Next, your consecutive angles, so that would be like x and y or x and y here, are going to be supplementary to each other. When we use that in an actual equation, we know that we need to add them together, so add the 2 side-by-side angles together to equal 180 degrees, and then we can solve for the variable. So this would be an example of how we could set that up. The last property is something about the diagonal, so Q, S, and PR, they bisect each other. This means that each of them are cut in half and they are equal to each other. So not all 4 of them are equal to each other, just the initial diagonal is cut in half and the other diagonal is also cut in half. In example 1, we're going to be using these different properties to find out what the different values of x and y are going to be. In the picture off to the side, we see that we are given parallelogram ABCD. So assume that it is a parallelogram. And that means that we know that the opposite sides are going to be congruent to each other. We also know then that the opposite angles, so angle B and angle D, will also be congruent to each other. Because we know they are congruent to each other, we can set them equal. So first we know that BC is congruent to AD. That tells us that the length of BC is equal to the length of AD, which means we can write the equation 5x plus 19 equals 7x. And now we can use this to solve for our x. If we subtract 5x from both sides, that would give us a 19 equals a 2x. So if we divide both sides by 2, that would give us that our x is equal to 9.5. We can use the x equals to 9.5 to find out what the measure of BC and AD are going to be. So probably the easier one would be to start with AD because we have just 7 times that 9.5. And if we multiply those together, we get a 66.5. So I know that AD is equal to 66.5. I also know that BC is congruent to it, so I can just say that BC is also equal to 66.5. Now if I want to find out what the angle measures are going to be, we know that angle B starts out being congruent to angle D because they're opposite angles in our parallelogram. That means that the measure of angle B is equal to the measure of angle D. And I can set 6y plus 5 equal to 8y minus 17, and now we can solve for y. If we subtract 6y from both sides, we get a 5 equals a 2y minus 17. I can add 17 then to both sides, so I get a 22 equals a 2y. When I divide both sides by my 2, y equals an 11. So when I solve for y, I can now put that back into either of the angles. So if I start with angle B, I've got 6 times 11 plus 5, so that would be 66 plus 5, which would be a 71 degrees for the measure of angle B. Measure of angle D should be exactly the same, and that would also then be a 71 degrees. Since it does say in the directions that we want to find out what angle C and angle A are, we know that they are supplementary to B and D. So if I take angle B plus angle C, that should equal 180 degrees. We know that angle B is already 71, so I can use that to find what my angle C is going to be. If I subtract 71 from both sides, I get that the measure of angle C is equal to 109 degrees, and that would be the same for my measure of angle A, would also be 109 degrees. So in this one question, we used a lot of properties about our parallelograms to find the missing sides and missing angles. In example 2, when we see the parallelogram PQRS, I see two sides that are opposite of each other, and we know that opposite sides in a parallelogram are congruent. PS then is congruent to side QR, so we can set those equal to each other. So 2z plus 4 will equal 3z minus 4, and we can use this to solve for z. We can then subtract the 2z from the left. We get 4 equals z, so 1z minus 4. We can add the 4 to the other side, and we get 8 equals z. Next, I see two diagonal pieces, and if this is a parallelogram, we know then that the diagonals will be bisecting each other. So PT, segments PT will be congruent to TR, and again we can set them equal to each other. So x plus 9 will equal 4x minus 6. If I subtract x off of both sides, that gives us 9 equals 3x minus 6. And I want you to continue going and tell me what the value of x is going to equal. You should have added 6 to both sides. That would give you a 15 equals 3x. Divide both sides by 3, and we get an x equals 5. On your second page, now we're on example 3, you need to find the indicated measure in parallelogram JKLM. We are going to be using lots of properties here, but again, we just want to break it down step by step. I see in the middle we've got some diagonals, and because it's a parallelogram, we know that they're bisected in half. So whatever one of the pieces is, the other one on the opposite side will be exactly the same. So since this is already a 2, then I know that NM will also be 2 for that measure. And then next they're asking what KM is going to be. Well, KM is the whole distance of that segment, so I can add the two pieces together. So 2 plus 2 equals 4. For the measure of angle JML, so JML, we need to look at the big picture, so without the diagonals in there. And if you notice, we have 110 degrees for angle J, and that tells me that this other angle will also be 110 degrees, but the side-by-side ones are supplementary. So if I take 110 plus the measure of angle JML, that should equal 180 degrees. So when I subtract the 110 over, we end up with only 70 degrees then is the measure of that missing angle. So if we take that measurement back over here into our picture, if we know the whole measure is 70 degrees, but the individual little piece is 30, then that tells me that if I take the 30 degrees that's already there and the measure of angle KML, and that's the missing piece, that together they need to equal 70 degrees. So all I'm doing is subtracting the 30 from both sides, and we get 40 degrees is the remaining angle of that other part of the angle right there. For example 4, I want you to do these on your own, so I want you to find the value of G and tell me how you are going to set up the equation for letter G. So because our two sides are opposite from each other, we know that the opposite sides will be congruent, so we can say that 25 equals 8G minus 3. And when you solve that, we would add 3 to both sides, so we'd get a 28 equals 8g. When we divide both sides by 8, we end up getting that g is 3.5. When we go on to letter F, now I want you to tell me what can we do with those 2 consecutive angles. So for letter F, what can you do with the 2 consecutive angles? The 2 consecutive angles are supplementary, so I can add F plus 30 plus the 72 degrees will equal 180 degrees. So when we combine our like terms, we got F plus 102 equals 180. When I subtract the 102 over, that gives us that angle F, or letter F, is going to be 78 degrees. For this last question, you need to pay attention to the letters in the order that they are given. So we give you A, B, C, so the first 3 letters, which means if we continue that around, so A to B to C, we're missing a point D that's going to be somewhere over here. So you need to be able to kind of estimate where that letter is going to end up. We know that the relationship between the opposite sides should be parallel to each other. So the lines are parallel to each other, and that means that they will have the exact same slope. So on letter B, when we need to find where the vertex D is, we need to use the slopes of our sides to make sure that they are identical to each other. So if we look at from A to B, we want to find out what the slope is from A to B, because the slope between C and D should be exactly the same. So if I start from B and I go up to A, then if I start at C and go up to D, that I should be able to find where that point is going to go. On my point B, if I go up and over, I would have to go up 3 spaces and over to the left. Let's see, 1, 2, 3, 4, 5 spaces. So my slope of side AB is 3 over 5. Now realize that the slope is a negative, but if I start at point C and I count the same direction, so up 3 spaces and over to the right 5, 1, 2, 3, 4, 5, this is where my point D should end up because I counted up 3 and over 5. I continued on the same pattern. This gives us that D is going to be at -2, 0. Next, we want to check the slopes of all 4 sides. We already know that the slope of side AB is a -3/5, and the slope of side DC is also a -3/5 because they are parallel to each other. So we need to find the slopes of AD side and BC. So I want you to find the slope of AD right now. You should have counted, or you could use the slope formula, but if you count on your graph, you could go up 2 and to the right 3. If we do the same thing for BC, then it should be up 2 and to the right 3. We can see that these last 2 pieces, these last 2 slopes are also parallel to each other, which means that our sides are going to be parallel.